In the history of the 20th century, few names carry the weight of both genius and madness like Howard Hughes. To the public, he was the eccentric billionaire, the Hollywood playboy, and eventually the hermit in the penthouse. But beneath the tabloid headlines lay a mind obsessed with the physics of flight and the precision of electronics. In 1932, in a corner of a Burbank hangar, the Hughes Aircraft Company was born. It didn't start as a defense giant. It started as a division of the Hughes Tool Company, a vanity project for a man who wanted to go faster than anyone else in history. Howard Hughes didn't just want to fly, he wanted to reinvent the airplane. He gathered a small team of brilliant engineers, including Richard Palmer and Glenn Odekirk. Together, they built the H-1 Racer. It was a silver bullet, a masterpiece of aerodynamics, with flush-riveted skin and a power plant that pushed the boundaries of the era. In 1935, Hughes himself piloted the H-1 to a world speed record of 352 miles per hour. 2 years later, he broke the transcontinental record. These weren't just stunts, they were the proof of concept for a new kind of company. Hughes Aircraft was built on the philosophy of total engineering. But as the drums of war began to beat in Europe, Hughes realized that speed wasn't enough. The future of aviation wouldn't just be about the airframe, it would be about the systems inside it. This small group of experimentalists was about to be thrust into the most massive industrial mobilization in human history. This is the story of a company that would build the largest airplane ever flown, the satellites that connected the planet, and the missiles that defined the Cold War. This is the story of the Hughes Aircraft Company. When the United States entered World War II, Howard Hughes expected to be the primary architect of the American air fleet, but Hughes was a perfectionist in a time that demanded mass production. His relationship with the military was fraught from the beginning. While Boeing and Douglas were churning out thousands of bombers, Hughes was focused on the D-2, a radical twin-engine fighter and bomber made of duramold, a plastic-impregnated plywood. Hughes believed wood was the future. The military, eyeing the scarcity of aluminum, was intrigued but skeptical. The D-2 project was plagued by delays. Hughes's insistence on micromanaging every bolt and rivet infuriated the War Production Board. Eventually, the D-2 evolved into the XF-11, a high-altitude reconnaissance aircraft. In July 1946, during the XF-11's first flight, a propeller malfunction sent the plane screaming into a Beverly Hills neighborhood. Hughes was pulled from the burning wreckage with near-fatal injuries. It was a moment that almost ended the company before its real work began. But while the aircraft projects were struggling, a small, quiet shift was happening within the company. In 1943, Hughes had formed a new division, electronics. He realized that the pilot of the future would need electronic eyes to see through clouds and darkness. This realization would save the company and change the world.
Perhaps no aircraft in history is as famous or as misunderstood as the Hughes H-4 Hercules, mockingly nicknamed the Spruce Goose by the press, a name Howard Hughes detested as the plane was actually made primarily of birch. Born out of a wartime need to transport troops and tanks across the Atlantic without being sunk by German U-boats, the H-4 was a monster. It remains the largest flying boat ever built, with a wingspan longer than a football field. But by the time it was finished in 1947, the war was over. The Senate War Investigating Committee, led by Senator Owen Brewster, hauled Hughes to Washington for a series of high-profile hearings. They accused him of misappropriating millions of taxpayer dollars for a plane that wouldn't fly. Hughes fought back with a brilliance that captivated the nation. He famously told the committee, "If the H-4 should fail to fly, I will leave this country and never return." On November 2, 1947, in the waters of Long Beach, California, Hughes sat at the controls. Before a crowd of thousands, the wooden giant lifted off. It only flew for about a mile and only about 70 feet above the water, but it proved the point. The Spruce Goose never flew again, but it stood as a monument to Hughes's stubbornness and his company's ability to achieve the impossible scale of engineering. As the late 1940s transitioned into the Cold War, the aircraft in Hughes Aircraft Company began to take a back seat to a new discipline, electronics. Under the leadership of Simon Ramo and Dean Wooldridge, two of the most brilliant physicists of the era, Hughes Aircraft became a magnet for scientific talent. The company developed the first advanced fire control systems for interceptor aircraft. Before this, a pilot had to manually aim their guns based on sight. Hughes created a system that used radar to track an enemy bomber and a computer to tell the pilot exactly when to fire. This was the birth of the electronic pilot. The Hughes E-1 and later the MA-1 systems made the F-89 Scorpion and the F-102 Delta Dagger the most lethal defenders of American airspace. While other aerospace companies were focused on metal and rivets, Hughes was focusing on bits and waves. They were pioneering the field of systems engineering. By 1950, Hughes Aircraft had become the dominant provider of airborne radar and weapons control in the world. But the success brought a new kind of tension. Howard Hughes's erratic behavior and his refusal to take the company public or create a traditional management structure were driving his top scientists to the breaking point. By 1953, the internal pressure at Hughes Aircraft reached a boiling point. Simon Ramo and Dean Wooldridge, frustrated by Hughes's lack of consistent leadership, resigned to form their own company, TRW. They weren't the only ones. Nearly the entire top management team walked out. To save the company from the IRS and to ensure its longevity, Howard Hughes performed a masterstroke of financial engineering. He created the Howard Hughes Medical Institute, HHMI, and donated the entire ownership of the Hughes Aircraft Company to it. This turned a massive defense contractor into a non-profit-owned entity. The profits from the missiles and radars would now fund medical research. It was a bizarre arrangement, but it worked. Under new management, specifically L.A. Pat Hyland, the company entered its most productive era. Freed from the immediate day-to-day interference of Howard Hughes, who was drifting further into his legendary reclusion, the engineers were given a simple mandate: invent the future. They were about to move from the cockpit of the fighter jet to the edge of the atmosphere. In the 1950s and 60s, Hughes Aircraft became the world's premier sharpshooter. They realized that the future of air combat wasn't dogfighting with machine guns, it was beyond visual range combat. The Hughes AIM-4 Falcon was the first operational guided air-to-air missile for the U.S. Air Force. It used heat-seeking and radar guidance, technologies that Hughes engineers helped perfect. But their masterpiece was the AIM-54 Phoenix. The Phoenix missile, paired with the Hughes AWG-9 radar, allowed a single pilot to track 24 targets and attack 6 of them simultaneously from over 100 miles away. It was a level of technological dominance that wouldn't be matched for decades. Hughes Aircraft was no longer just an aircraft company, it was a weapons systems company. They were the masters of the kill chain. But even as they were perfecting the art of destruction, they were also pioneering the art of global communication. In a quiet lab in Culver City, a group of engineers was working on a project that would change how every person on Earth saw the world. In the early 1960s, the idea of global live television was a dream. If you wanted to send a signal across the ocean, you had to use undersea cables with limited capacity. A Hughes engineer named Harold Rosen had a radical idea. He believed a satellite could be placed in geosynchronous orbit, 22,300 miles above the Earth. At that altitude, the satellite would orbit at the same speed the Earth rotates, effectively hovering over one spot. Most of the industry, including NASA, thought Rosen's plan was impossible. They thought the launch would be too difficult and the signal delay too great.
But Hughes backed Rosen. In 1963, SYNCOM-2 became the first successful geosynchronous communication satellite. The impact was instantaneous. For the first time, the world was truly connected in real time. This led to the creation of the Hughes Space and Communications Company. They went on to build the Intelsat series, the Mariner 10 probe to Mercury, and the Pioneer Venus multiprobe. Hughes Aircraft had put a mirror in the sky. They had invented the infrastructure of the modern information age, but they weren't done with space yet. They were also going to be the first to land softly on the moon.
Before Neil Armstrong could take his giant leap, NASA had to know if the moon would even hold his weight. Some scientists feared the lunar surface was covered in a deep layer of dust that would swallow any spacecraft that tried to land. The task of finding out fell to the Hughes Surveyor program. On June 2, 1966, Surveyor 1 performed the first fully controlled soft landing on the moon. It sent back thousands of high-resolution images of the lunar soil. Hughes built 7 Surveyor spacecraft. 5 of them landed successfully, providing the vital data that allowed the Apollo program to proceed with confidence. The Surveyor program demonstrated Hughes's incredible versatility. They could build a missile that traveled at Mach 4, a satellite that stayed perfectly still in the sky, and a robot that could land gently on another world. By the late 1960s, Hughes Aircraft Company was at the absolute zenith of its prestige. It was a national treasure of engineering. But the man at the top was disappearing. In 1960, a Hughes Research Laboratory scientist named Theodore Maiman achieved something that had only existed in science fiction. He built the world's first working laser. While other labs were racing to build gas lasers, Maiman used a synthetic ruby crystal in a high-intensity flash lamp. It was a solution looking for a problem. Hughes Aircraft quickly found those problems. They developed the first laser rangefinders for tanks and aircraft. They created smart bombs that could follow a laser spot to a target with pinpoint accuracy. This technology revolutionized the battlefield, reducing the number of bombs needed to destroy a target and minimizing collateral damage. Hughes was also a leader in infrared technology. Their night vision systems allowed pilots and soldiers to see in total darkness by detecting heat. From the depths of the sea to the vacuum of space, Hughes sensors were everywhere. The company had become the senses of the military. They provided the eyes, the ears, and the nervous system for the modern American war machine. In April 1976, Howard Hughes died aboard a flight to Houston. He left no valid will, sparking a decade-long legal battle over his estate. But the most valuable asset he owned was the Hughes Aircraft Company, still held by the Howard Hughes Medical Institute. By the early 80s, the IRS was pressuring the institute to sell the company. It was the sale of the century. Every major industrial player, Boeing, Ford, Lockheed, wanted a piece of Hughes. In 1985, General Motors won the bidding war, paying a staggering $5.2 billion. GM wanted Hughes not for its missiles, but for its high-tech DNA. They hoped Hughes engineers would help them build the car of the future. For a few years, there was a strange synergy. Hughes tech appeared in Cadillac dashboards and head-up displays for cars. But the cultures of Detroit and Southern California were worlds apart. The rigid, bureaucratic world of GM struggled to integrate the university-style freedom of Hughes. While the automotive side was a mixed bag, the satellite side was about to launch a consumer revolution. In the early 1990s, Hughes Aircraft Company, now under the GM umbrella, embarked on its most ambitious consumer project, DirecTV. They used their high-power HS-601 satellites to beam hundreds of channels of digital video directly to small 18-inch dishes on people's homes. It bypassed the cable companies and changed the television landscape forever. DirecTV was a massive success, but it also signaled a shift.
Hughes was becoming a service provider rather than just an equipment manufacturer. However, the end of the Cold War brought a peace dividend that hit the defense industry like a sledgehammer. The massive budgets for Phoenix missiles and secret radars were being slashed. The industry began a period of hyper-consolidation. General Motors, facing its own financial struggles in the auto market, began to dismantle the empire Howard Hughes had built. In 1997, General Motors sold the defense operations of Hughes Aircraft to Raytheon for $9.5 billion. The satellite division, the part that built the mirrors in the sky, was sold to Boeing in 2000. The name Hughes Aircraft Company officially vanished. The Tucson missile plant became a Raytheon facility. The El Segundo satellite lab became Boeing Space Systems. It was the end of a corporate identity, but it wasn't the end of the technology. If you look at an F-22 Raptor today, its radar is a direct descendant of Hughes designs. If you use a GPS system or watch satellite TV, you are using Hughes pioneered technology. Even the medical research funded by the sale of the company via the Howard Hughes Medical Institute has led to dozens of Nobel Prizes. The empire was gone, but the DNA was everywhere. What is the legacy of Hughes Aircraft? To some, it is the story of a man's obsession. Howard Hughes was a difficult, often impossible leader. He demanded 24-hour work cycles and absolute secrecy. But his willingness to fund crazy ideas like the geosynchronous satellite or the laser created a sanctuary for genius. The Hughes culture was unique. It was a place where physicists, mathematicians, and tinkerers were given the resources of a superpower. They were encouraged to fail so long as they failed forward. From the car radio to the lunar landing, the fingerprints of Hughes Aircraft are on almost every major technological achievement of the American century. They took the black magic of electronics and made it a tool for the masses. The story of Hughes Aircraft Company began with a single man in a cockpit chasing a speed record. It ended with a global network of satellites and sensors that define our modern existence. It is a reminder that innovation often requires a touch of madness. It requires someone willing to build a wooden plane the size of a city or to bet billions on a hovering star. Howard Hughes may have ended his life in shadow, but the company that bore his name lived in the light of the future. They were the dreamers who gave us our eyes in the sky and our voice across the stars. The aircraft is gone, the man is gone, but the empire of innovation remains. Hello, Moto. Wait, wrong script. The future is Hughes.